All right, for this video, I'm going to be reviewing two separate scale models of the solar system demonstrations. And this first one is put together by Fun Science Demos, and then I'll show you the second one, which I really like. But let's get started on this. We'll give you some audio, and we'll come back.
Hi, I'm Jared, and welcome to Fun Science Demos. The big idea today is big. We want to look at how big our planets are compared to the sun and how far away they are from the sun. So let's look at the first three planets closest to the sun. We have Mercury, Venus coming second.
So he starts here talking about the planets themselves and their relative size to a scaled down sun. And I think this is good. But the focus of this video is actually not on the size of the planets. It's actually on how far away they are. And so in just a minute, he goes out into the hallway and talks a little bit about that. I think this is good stuff. This is really important information for students to understand in an astronomy class, as the scale of astronomy is pretty astronomical. Let's take a look at his hallway.
To take a look at how far away the first three planets are away from the sun. The marathon's going to begin because we have our planets on sticks, and I'm going to make my way down there and shout out the distances so you can see how far away those planets would be away from the sun if the sun were this size. The sun's not this size. It's really big. So here we go. We're going to start with Mercury. Let's go. I'm standing at Mercury. It's about 20 meters away from the sun. What about the next one? On to Venus.
So this is good. He runs down the hallway to the distance away that Venus would be, and then finally the Earth, and then he works his way back. It's a good demonstration. Again, much like the other demos I've seen from Fun Science demos, this seems like something you could do in school. So it's something that we could do with my students if I was able to get those materials and have that conversation. So I think this is good. I do think it's a little bit limited. So I'm going to move on to a second video, which I find to be one of the best videos. It's won awards and everything, but it's a video that does a scale model of the solar system using a bigger scale and using the Black Rock Desert and cars. It's just absolutely amazing. So let me give you a little bit of this one.
If you look up an image of the Earth and Moon, you're going to get a picture where they're quite close together. Something like that. But in reality, the Earth and Moon are about that far apart. That is the Earth and the Moon to scale. Taking the same concept, but for the solar system, every single picture of the solar system that we ever encounter is not to scale. If you put the orbits to scale on a piece of paper, the planets become microscopic and you won't be able to see them. There is literally not an image that adequately shows you what it actually looks like from out there.
I think this is great because they talk about the problem of scale models and how challenging it is to actually talk about our solar system from a scale standpoint. And so they present the problem really well, and then from here they move on out into the desert and actually start to build a scale model. And so again, I'll jump ahead a little bit because it takes a minute for them to kind of get out there and talk about what they're going to do. But let's keep going here. So there's their sun. I think it's 1.5 meters in diameter.
The sun is 1.5 meters, so about that big around. So we are driving right now to Mercury, and we've arrived. Venus is the same size as Earth. There's a world in my pocket somewhere. And Earth. And this is Mars. Got a couple of robots rolling around on that one.
So again, you start to get the idea of how this video works. They've done an amazing job. They have the drones coming up above and giving you the view from on top. And then they actually do time-lapse shots of these lights as they move them around on cars and show the objects orbiting around at the rates that they'd be orbiting to. I know this is a relatively in-depth project. Here's Jupiter. And again, showing the distance, I think it's just great. But these guys just kind of got together and did this, and I think it's amazing. What I like about it, in contrast to the other video, is this is something that I could not do in my classroom. They've done something with a high-quality product that really demonstrates something that I would have a ton of trouble doing in my room. And I think it's amazing. And this, to me, is the kind of demo that I think is worth my time in showing in class. And to be honest, I have shown it before because I think it's such a good model that describes our system in a larger sense. And so I'll move kind of towards the end a little bit here. One of the things that I really, really like that they talk about is how you know here at sunrise, how you know the model works, because from the Earth, and they're standing at the Earth, holding up the sun, and then they watch the sun rise, and their model sun eclipses the real sun, showing that the scale size is the same. And you know, when I've done this demo with my students in class, I've asked them how they can explain this and how it's similar to stuff that ancient astronomers did. And I think it's a really good discussion. So this is great. And at the very end of the video, they go on and do some inspirational stuff about, you know, space travel and exploration and how we've only gotten to the moon and so on. So this to me is a fantastic demonstration. Using it in my class in the past, I've used it as an introduction to scale models. What I think is neat from here is you can then move out and start talking about scale models of things at an even larger scale, and move out to talking about scale models from stars to stars and galaxies to galaxies. In my next review, I'll review a demo video where they talk about scale models of stars, which I think is a really good place to go.